Hey class, this week we are going to be going over templates. This is going to be a lot shorter of a video. Templates aren't that hard to wrap your head around, so hopefully we'll be able to get through it and you guys can get a head start on your homework. So the cool thing about templates is they are a way for you to create generic and reusable code. So if you remember a few weeks back when we learned about overloading operators, or not operators, overloading functions, we learned that you could define a function, give it an integer data type, and then later define that same function, but maybe give it a double data type, and then you can call that function multiple times. Really useful stuff, but it took a lot of space, and it was kind of cumbersome, and you can kind of get lost in the weeds because you're essentially duplicating your code multiple times. Templates are a good alternative to that because you only have to create the function once, but you kind of give it this generic data type, and then every time you call the function, you can kind of plug and play what that data type is each time that you call it. So here's some examples. Here's an example of a template just on a function. And then here's an example of using a template on an object. So this is a struct, but you can do the same thing with a class. What's really important is you always put this code right here, the template type name T. You always put this first before the function. So every time you're about to code something that is templated, you have to put this right before it. What's necessary is you have to put template here. You have to put the angle brackets and then type name. In earlier versions of C++, you could actually type the word class. It's kind of bad practice now to type class because, for obvious reasons, we use classes for different things. So it's much better practice to put type name here. And then T is just the name. You don't have to put T. It's kind of a common practice to do that. You could name it whatever you want. But this is kind of like your stand-in for what that variable or what that data type is going to be. And then if you look here with this function, we put our return type. Well, our return type is T, right? Whatever it's going to return depends on what we're feeding it. I have the function and then the parameters, and then these are also type T. Now, understand that you can't mix and match different data types here. If you define T to be an int, then T needs to be an int through all of it. If you define it to be a double, it needs to be a double through all of it. We'll talk about in the next few slides how you can have multiple different data types within a template, but for this example, if it's type name T, whatever I define T as in this instantiation needs to stay that throughout. And then over here on the right here, it's kind of the same thing. You put your template, and then with my struct here, notice that height is of type T, so that's why I had to template it. Okay, so two template classes is what we just talked about. Let's say for this example, you want height to be integer and you want weight to be double. What you do is within the template, you just have to create multiples here. So you still put type name, you put your name, you separate it with commas, and then you keep writing type name and then your name, and you can do this as much as you want. But in this case, everything T1 has to be a data type, and then everything T2 can be a different data type. So in this case, if I want T1 to be an integer, then T1 has to be an integer throughout the entire thing, and then T2 can be a float or double or whatever. Okay, instantiating templated objects. So an object would be something like a struct or a class, right? It's this container, this encapsulated container, and then I can declare an object of that. So if you look here with that person struct that I made earlier, I am declaring that object. It's of type person, but notice that I have to put the angle brackets, and then I have to put the different templated types. So in this example, since person has two templates here, in the angle brackets here, I have to put the two templates. This represents T1, this represents T2. So this has to represent height, this has to represent weight in this case. And so notice that height is an integer, weight is a double, or float, or whatever I said. Yeah, double. So yeah, so whenever you call an object, so whether that be a class or a struct, you need to put in angled brackets right after that data type. You need to put what the templates are for that. So I thought I'd give you some examples. You can go through these slides on your own time and kind of see what the examples are. I kind of wanted to code a few right now, so you can kind of see what's going on. So if you wanted to make a function that's templated, let's say you want to add two variables together, you do something like this, right? Let's say it's int, let's call it add, then int a, int b, and then a plus b, something like that, right? Super, super simple. And then down here we would do something like that, right? Save it, build it, run it, and get your answer. Really easy. But let's say we wanted to not just add integers, but let's say we wanted to add doubles, right? So we'll call this double, and we'll do 7.9. So notice it may work. Let's see what it does. So it worked because doubles and integers can work together a little bit nicely, but notice that it didn't keep the precision. And it didn't keep that precision because the return type is integer, right? So it just kind of cut off that precision. So if we wanted to keep this precision, well, what we've learned earlier is we could overload this by just, duplicating it again. But we don't want to do that here. Instead, we're just going to template the function. So right above the function, you type template, and then you put those angled brackets, type name, T is what I'm going to call it. I'm going to change the return type to T here, and then the parameters I'm passing, I'm also going to call those T, right? And then once I do that, type name T, I should be able to save. Let's build it, and we kept that precision. So that's just a really nice quick way that you could, instead of overloading it, you could build a template. So what's really cool is we could do this a third time. Let's call it string. E and F, build, run, and look at that, it works the third time. Now, like I said, whatever I define the template to be, it needs to stay that. So I couldn't, make E a string and then F a double again, because I couldn't do something like this, and you can see it's pretty mad at me, because once you define what T is, it needs to stay that way. So it's, pretty mad at me. So just remember that. If you wanted to have multiples here, you'd have to separate by a comma and template a couple of different things. So now I wanted to show you maybe in the case of an object. So let's do a struct again. And I'll call person. And then here, you can do whatever you want. I could do string name. I can do double weight, and then I'll do T height. That's not how you spell that. Just like that. And then really what I wanted to show you here is when you instantiate that object. So, before you do like person P, something like that. But now that it's templated, I actually have to put in the angled brackets what the template is. So I could do something like that. Oh, and it's mad because I need to put my semicolon there. So it would look something like this, right? And that's the same thing if you do a class. Instead of a struct, if you made this a class, and you could have your private variables and your public, and you would have your constructor, whatever it is, and then let's put that here. And yeah, it's mad at me for some reason. I probably forgot something. Anyway, but it's the same thing. You would put your template here, and then whatever your templated things are, and then down here, when you instantiate that object, you would need to put what that type is. Anyway, that's honestly all I have for this week. Templates really aren't that bad. So good luck. Let me know if you have any questions, as always. And I look forward to looking at your guys' homework.